Welcome back to the QST channel. Today we are going to be solving Physics CA quiz for non-transitional year. Alright, let's get started. The nuclear reaction where a heavy nucleus splits into two lighter nuclei upon bombardment by neutron is called fission. Okay, so what that means is when the nuclear reaction, there's a nuclear reaction when the big heavy nucleus is bombarded by neutron, it's going to split into two nuclei, two smaller nuclei, okay? And that is called fission. It's memorization, alright? On to the next. Which of the following are disadvantages of nuclear energy? In case of failure of the protective covering, radiation can seep through the environment. That is true. Nuclear plants pollute the environment with greenhouse gases. That nuclear plants do not exist. Okay. The half-life of nuclear waste is often very long. That is right. That's true. As we studied with half-life, for example, carbon-14. Its half-life is 5,760, if I'm not wrong. Okay. Nuclear plants significantly contribute to global warming. As we said, it does not make a difference, and I don't think they exist. A very large amount of fuel is required to run a nuclear plant. That is false, because there actually no amount of fuel is required to run a nuclear plant, because the reactor is producing the energy. Okay, on to the next. Which of the following statements describing the safety measures while using radioactive materials are true? Make sure it's safe to move a radioactive source with your hands. Logically, if you think if I hold uranium with my bare hands, they're gonna mutate. So it's no, I'm gonna die because it's gonna mutate and it's gonna decay, releasing radiation that will alter my DNA cells, mutate my DNA cells, so I will die. That is wrong, no. Make sure that a radioactive source is pointing away from you. That is true, that is right. Radioactive sources should be identified using your eyes only. No, they should not be identified using only your eyes. That does not make sense. Radioactive sources should be locked up in a safe place. Example, a lead box. That is true because they release radiation, and lead stops, like slows down most of the radiation. But lead completely stops alpha and beta, but gamma it slows it down. Eating is allowed when handling radioactive sources. That is a big no, and it is logic. This type of question is logic. Alright, on to the next. Which of the following are advantages of nuclear energy? It does not contribute to the greenhouse effect. That is true. And first, let's go over the options. Psychological bias against nuclear energy. That is not an advantage. That is a disadvantage. Because bias means people the meaning of bias is like, for example, let's say your dad's brother has a restaurant, okay? And there's another restaurant and the food tastes better. Your dad, of course, is gonna say his brother's restaurant is better because he is his brother. That's biased. He's biased right there. So here people, they're psychologically biased against nuclear energy because of what happened in Chernobyl. So they are biased because of the things that happened in Chernobyl. So they are against nuclear energy, no matter how safe it is. And today, the chance of a nuclear failure is close to zero, if I'm not wrong, based on the book. Okay, they can be built everywhere, including city limits. No, they cannot be built next to living quarters, let's say, because it releases radiation. Not all radiation is stopped. It could affect humans. That is why workers in nuclear facilities, they need to wear protective gear to stop the radiation, not to slow the radiation down, to minimize the damages inflicted. It does not contribute to the greenhouse effect because it does not release smoke or it does not release carbon dioxide. Power plants does not require protective material. No, it does, because if there's no protective material, then basically the entire area is gone. The radiation will mutate all of the DNA of any living creature nearby. It runs on a smaller amount of fuel compared to coal plants. That is true. All right, on to the next. The internal energy of a system can be thought as the sum of the two random kinetic energies and the chemical potential energy and the intermolecular potential energy of its particles. This is it's eternal energy of a system. It's logic as well. It's memorization, but it's logic if you think of it. Eternal energy is its kinetic energy, its potential energy, of its chemical potential energy, and its intermolecular potential energy. All right, on to the next. Depending on the context, heat energy can refer to a random thermal energy, internal energy, and radiant energy. Let's see, there's another choice, light or electromagnetic, okay? So heat, it can be, let me write it down. 1 second. So heat is basically thermal energy. Heat is thermal energy. All right? 1 second, let me make heat is thermal energy. And it is internal energy, radiant energy, because it radiates heat. For example, thermal energy is logic, we know that. Eternal energy is like, for example, how can I explain it? For example, it's like the heat of its atom particle, okay? Radiant, I spelled it wrong. Radiant, it is, for example, let's say you are standing in front of the microwave, for example. You are looking at your, for example, pizza spin in there, and you feel the heat coming at your face, okay? That is the radiant energy. It's the radiated energy from the microwave, and it goes onto your face. It's radiated energy. And there is light energy, which right now you can see how you are watching this video through this tablet. It's light. And we have electromagnetic energy. Electromagnetic radiation or energy, we'll just call it energy, which is basically electromagnetic waves that are traveling through this matter or vacuum. For example, how does the sun's light rays get from the sun to here? It's electromagnetic energy. All right? On to the next. Which kind of the following affects the rate of a radioactive decay reaction? Okay, here it's memorization. The quantity of the radioactive material, which is the amount of it. For example, let's say the half-life of carbon 14, for example, is, we said, let's round it, 5,800 years, all right? And what if, let's say, I have 100 grams of it, okay? The 100 grams is gonna last longer than the 50 grams, right? It's gonna be, it affects the rate of the radioactive decay because it's still going to be like more than the 50 gram one, right? And it's the kind of radioactive material. For example, 1 second. Okay, for example, the half-life of uranium is approximately 4.5 billion years. And the half-life, we're talking, and for the half-life of, for example, carbon, as we said, 5.8 thousand years, 5.8k years, like approximately as well. So what we said is the kind of radioactive material, it matters, because for example, carbon 14 is going to decay after 6,000 years, okay, while that's its half-life, okay, and uranium, by that same amount of time, the rate would be much slower. Like, so the kind of radioactive material does affect the radioactive decay reaction. Okay, on to the next. Which of the following are advantages of nuclear energy? It limits the production of carbon dioxide. It contributes in global warming. It limits the production of acid rain. There will be no shortage of fuel for nuclear energy. There will not be shortage of fuel for nuclear energy. It's because, firstly, the nuclear energy, it never stops. It never stops radiating. Even though it's minuscule, it will never stop radiating. Okay, don't forget that. The time required for half a given quantity of radioactive material to decay is half-life. The ability to cause a change is called energy. This is memorization here. A bottled gas is used to make a hot coffee pot. What energy is stored in the bottled glass? It's chemical energy, potential energy, because the energy is still not put in. It's still waiting to be used, okay? To what form of energy is the energy in the bottled gas transformed after combustion? It's heat energy, because they said combustion, which means it's going to react vigorously in high temperatures or heat, okay? Drag and drop the correct answers to complete the sentences below describing the origin of the energy in the bottled gas. The solar energy is absorbed by living organisms, okay? For example, plants. Those organisms die and are degraded in the soil under high temperature and pressure, okay? Fossil fuel is thus formed because we said energy based on it's like a rule. Energy cannot be created nor destroyed, okay? So this energy, it will, under high pressure, it's going to turn into fossil fuel, which is highly concentrated energy. That's what cars used to run on, what cars are running on, petrol. Okay, it is very reactive. It's highly flammable. Okay, and it is then processed in fractioning towers, and gas is separated and bottled for house use. Okay, on to the next. Match every form of energy to its corresponding description. Sorry about that. Eternal energy is related to random thermal energy. Okay, let's go to the obvious ones first if you don't know what eternal energy is. Chemical energy is a form of potential energy stored in chemicals and in food. You have the keyword chemicals. Okay, heat. Okay, heat energy refers to the hotness of a body. Hot and heat, keywords. Eternal energy related to random thermal energy of the particles in their intermolecular and chemical potential energies. So here it is very obvious, they said intermolecular, so immediately I know it is eternal energy. Let's go to the next question. Sorry about that. The solar energy is absorbed by living organisms and stored as chemical energy. Organisms die and decompose over years, changing to fossil fuels, and when burned in cars release their energy as mechanical and thermal energy. Okay, here they said the solar energy is absorbed by living organisms, plants, and it's stored as chemical energy. Once they die and decompose, okay, over years, they will change into fossil fuels. That when buried in cars, okay, release their energy as mechanical and thermal energies, which is petrol. Okay, on to the next. And Einstein's mass energy equation shows that mass m can be converted into energy E. The equation that describes this relation is E equals mc squared. E is energy, m is mass, c is the speed of light, which is a constant. Okay, let me just write it down. As we can see here, E is energy, as I wrote down. M is mass, C is the speed of light, which is equal to 3 times 10 to the power of 8. Okay, if you would like to screenshot it now. Okay, let's go on to the next question. Oh, I didn't read this. In nuclear reactions, the mass of the products is less than the mass of the reactants, because the products, they're released in many forms. They're released in particles and electromagnetic waves, which is energy. When energy is lost, mass is lost as well. Okay, on to the next. Carbon isotope decays to become a nitrogen isotope as shown below. This is really simple. Let me just write. Firstly, they want us to find AZX, okay? They just want us to find A and Z. A is equal to, Z is equal to Z. Okay, for A, they say here C15, which is on top, the mass number is 15, and N is 15, so A is 0. Immediately I can say it's a beta decay. Okay, so here nitrogen is 7, its atomic number is 7, so Z has to be -1, because it's lost a proton. Okay, so it's a beta minus decay. Let me write it better. 1 second. Beta minus decay. Okay, on to the next. Okay, for this one, the background, the graph below shows activity due to a given radioactive as measured by a detector. The background radiation level is 25 counts per minute. What is the measured count rate of the source alone at 0 time? Okay, say here they want the source alone. Source alone is the count rate measured by the detector, which is 120, minus the background radiation level, which is 25, minus 25, you will get 95 counts per minute. Okay, after one half-life has elapsed, what's the count rate due to the source alone? Okay, source alone, so you do 95 divided by 2 half-life. Put this into your calculator, 95 divided by 2, you get 47.5. Let me write it here, which is the answer here, given here. After one half-life has elapsed, what is the count rate measured by the detector? Okay, here you might think you do 120, half 120 to get the half-life, but it's wrong. Background radiation is always constant, it never changes, it never dies out. So what you do is the half-life of the source alone plus the background radiation, which is 47.5 plus 20, which is 72.5, which is the answer here. What is the approximate half-life of the source? Okay, we find here the half-life that is measured by the detector is 72.5. Let me just draw it on the graph and I'll be back. Okay, as you can see here, we graph 72.5 on the graph, which is over here. Okay, and which is half of here, and we get 7 minutes, between 6 and 8. 7 minutes. Okay, on to the next. A wooden instrument found in the archaeological excavations was found to contain 12.5% of its original carbon-14 content. The approximate age of this instrument is how many years? Okay. Here, what I'd tell you to do is, 1 second. Okay, so here what you do is, you see here that, 1 second, let me open the screen right. They say here the wooden instrument was found to be 12.5% of its original carbon-14. Okay, the approximate age of this instrument is, okay, first we know half-life is 1/2 to the power of 1, which is 50%. 1/2 to the power of 2. 1 second, let me just draw it. 1/2 to the power of 2 will give me 25%. But 1/2, 1 second, 1/2 to the power of 3 is 12.5%. Okay, it's easy. You just, for example, let me just do it this way. 100/2, you're gonna get 50%. This is 1 half-life. Over 2, 25%. Second half-life. Over 2, 12.5%. Third half-life. So here all you do is 5,700 times 3. Alright, that's it. The principle of conservation of energy states that energy of an isolated physical system remains constant regardless of the eternal interactions in the system. This is a memorization. It's a principle of the conservation of energy. So it states that the energy of an isolated physical system, it remains constant regardless of internal interactions with the system. Energy is transferred from the battery. Okay, as the current flows in an electric circuit, a battery provides energy to the circuit. So the battery is the source and the circuit is the sink, which is what's taking this energy. So the energy is transferred from the battery to the circuit. Alright? Okay, here as we said, if you go in 0, 1, you see E. 0, 1. Let me just. Okay, E0, 0, E, negative 1. It is a beta minus decay. E is beta. Immediately, once you see B, it's beta. Which of the following objects contain potential energy? It's fossil fuel, because you need to burn it to get its energy, to convert it from potential chemical potential energy to kinetic energy. And you have food, for example, a donut, for example. You need to break it down from chemical, and you need to break it down from chemical potential energy into chemical energy, which is nutrients. Basically, you need to break it down from potential to kinetic. On to the next. Which of the following statements are true? Electromagnetic radiation can propagate in medium Electromagnetic radiation can propagate in vacuum, and radiant energy can travel faster in outside matter. Okay, so the electromagnetic radiation can propagate in a medium, which means a vacuum. It can, okay, because it's radiation. That's how the light from the sun reaches us. Electromagnetic radiation can propagate in a vacuum. Same, it can propagate through matter and a vacuum. Radiant energy can travel outside matter, which is space, basically nothing. Okay, on to the next. Sorry about that. A bob of conical pendulum moving is an interaction without energy exchange because it's moving uniformly. A spring being compressed, which means there's an unbalanced force pressing it down, which is with energy exchange. A bob on a vertical swing is swinging up and down. It is an interaction with energy exchange because the spring is swinging up and down, so it is being pressed on by an unbalanced force. A man holds a heavy box above his head. He's putting it on his head. He's not pushing it down or pushing it up. It's just on a surface. So there's no unbalanced force is acting on it. A body is changing its speed but not its direction of motion, so it's interaction with energy exchange because it's changing its speed. A body is changing its direction of motion and its speed, of course it's energy. A body remains stationary without energy exchange, and the body is changing its direction but not its speed. There is no exchange in energy because it's the speed is always, since the speed is constant, we don't care about direction. As long as the speed is constant, no forces are acting on it, which means no energy exchange. Alright, on to the next. To charge your mobile phone, you plug it into a socket, supplying it with electrical energy. Okay, so when you charge your phone into a socket, you're supplying it with an electrical energy. This energy is stored in the battery as chemical energy. Okay, and when your phone rings, the energy is converted into sound energy, and when it displays the name of the caller, it's converted into light energy. Sound energy is this is how you're hearing me right now. Chemical is how all of this is happening in the first place because your battery is charged. And the light energy is how you're seeing this right now. Okay, when the energy changes from one form into another, we say that energy is transformed. So it's changing is the keyword. Transform, changing. When the energy is given from one body to another, we say it's transferred. So given is transferred. So you're giving it to someone, you're transferring it to something else. But when I say I'm changing it from one form to another, it's transforming. So because we're changing. Okay? Which law of physics states that energy of the isolated system dilutes itself? The second law of thermodynamics. Okay? Random molecular what is the most dilute form of energy? It's random molecular kinetic energy. This is all memorization and logic in the same time. Sorry about that, I'm back. Drag and drop the correct answers to complete the diagram below, describing the energy transformation that occurs in the sun. Okay, so there are two deuterium atoms, which are light. Okay, and they fuse together to make a helium atom, and they have leftover energy, chemical energy, thermal, light, kinetic, potential. It could be all of them, but they're all considered energy, so there's an additional energy left over. Okay, thank you guys for watching this video. I hope you liked it. Good luck with your exams and have a great rest of your day or night. Bye.